Hello dear students and very good evening to all of you guys, and in our today's session we will discuss the various problem which is related to the kinematic indeterminacy guys. Okay, and I hope all of you have covered the previous session in which we have discussed about the static indeterminacy as well as the kinematic indeterminacy part. In yesterday class we have completed the kinematic indeterminacy formulas. What are the various formula we have to calculate the value of dk in various structure like a rigid jointed structure, pin jointed structure, whether it's 2D structure, whether it's 3D structure. So these type of thing we have already discussed in our previous class. Okay, so in today class we will just solve the question which is related to the dk portion, and some of the question are related to ds also. Okay, so let us start this particular class guys. Let us start it. So these are the topic which we will cover today, which is basically the kinematic indeterminacy questions, and some of them are PYQ also, right? And in previous class we have discussed what is dk, how to calculate it, what are the various type of structure in which we need to find out the dk, like this we have discussed it, and some of the problem we have covered. Okay, so let's start this particular session guys. Okay, so this is the first question which I want to discuss over here, which is related to the bracing system, and this question was asked in GATE 2024. Okay, this question was asked in GATE 2024 guys, and that's why this particular question is also important, because in this particular condition you are not able to apply the formula directly guys, because in this particular case we have some bracing condition, and that bracing condition will try to stop the horizontal displacement. That you need to understand. Okay, okay sir, okay sir, okay sir. So let us discuss this particular question guys. What we have to do over here, let us understand this. Okay, if you apply the formula over here, or if you apply the formula directly in this particular question, then what will happen? You are not able to get the correct answer for this, right? So it is my suggestion guys, try to understand the concept of kinematic indeterminacy. Otherwise what will happen? You are not able to get the correct answer for this. Okay, so let us read the question first, or yes, let us read the question first, what it is exactly. The plane frame shown in the figure has fixed support at joint A. This is basically fixed support, and hinge support at F. This is basically hinge support at F, and roller support at I. This is a roller support at I. In the figure, A to I indicate joint of the frame. Okay, they are basically from A to I, all are the basically joints. If the axial deformation are neglected, then you need to find out the value of dk. You need to find out the value of dk. What is the value of dk for this particular problem? That is the question which is given to us. Okay sir. So guys, what will happen? Let me explain. If you not allow any kind of axial deformation in the member, that means the member is not trying to extend along its length. That is the general rule as per this particular statement. The member is not able to extend or compress along its length. That means the axial deformation is basically zero, right? So guys, in this particular structure, there are some member which is basically beam, and there are some member which is basically column, right? So we know that guys, if we consider any joint, so at that particular joint, the vertical displacement as well as the horizontal displacement cannot be possible. Why it is so, sir? The reason is why it is so, let me explain. Because if you take delta 1 in the vertical direction, in such condition our column will become extensible, which is not possible as per this statement. If you consider horizontal displacement, in such condition beam will become extensible. Again, that such condition is not applicable in this particular problem, right? Or as per this particular statement. So guys, due to this reason, we have only rotation which can be possible at the joint. So let us write it down. Theta 1, this should be theta 2, this is theta 3, then theta 4, this is theta 5, this is theta 6, this is theta 7, and this is theta 8. This is theta 8. theta 1, theta 2, theta 3, theta 4, theta 5, 6, 7 and 8. Understood? Understood? And there is one more displacement which can be possible, that is basically delta 9, right? So total number of displacement for this particular structure is equal to how much? It should be 9. It should be 9. Understood? But guys, again you may have some question, sir, why we are not considering any horizontal displacement at this particular roller support? Why we are not considering any horizontal displacement at this particular level of the structure, at this particular level of the structure as a sway? Why we are not considering? So let us draw a one figure without bracing condition and try to calculate the value of dk first. Then we'll discuss what will happen if you apply some bracing in the structure, then which type of displacement will get 0. Okay, let us draw this particular figure, guys, again without bracing. Okay, without bracing. First, let us understand this one also, guys. In without bracing condition, what will be the value of dk, that we have to calculate first. Okay, then you are able to understand why we are writing this particular value as 9. Okay, I need to remove this brace condition we need to remove first. Remove it. This support is fixed basically. This one is fixed. This one is hinge. This one is roller. Correct? Roller, hinge, fix. And we have free end and 2 boxes. 1, 2. Okay, that's it. So guys, this is the structure which we have, right? This is the structure which we have basically without bracing condition. So first, let us calculate the value of dk in without bracing condition. Okay, let us calculate the value of dk, which is basically 3j minus re minus nr plus r dash. This is the formula. So let us calculate it, how much it is. So how many joints we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 joints are there. So we can write here 9 minus re. How many reaction we have? 3, 2 and 1. That means total number of reaction is 6. What is the value of nr? nr is basically the number of member which is axially rigid. Axially rigid. So right now, how many member we have which are basically axially rigid? All of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can write here, guys, the value is 10. And the reaction release value is 0. So what will be the answer in this particular case? It is 27. And this is basically 16. So 27 minus 16 is equal to how much? It is 11. So guys, this is the answer which we are getting in which bracing condition is not given. We can write here unbraced frame. This is basically unbraced frame. Now let us understand what are these joint displacement which is present in this particular structure. So let us draw it first. So you can see here, guys, this is theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7, theta 8, then delta 9, delta 10 and delta 11. Now guys, listen very carefully. You don't have any kind of horizontal displacement at the roller support. The reason behind it is the member is inextensible. That's why this linear displacement is not possible at this particular joint. Okay. Now guys, whenever you apply some brace or some bracing member, then these bracing member is trying to stop the lateral displacement of the structure, or these are to be used to stop the sway value, or you can say that we want to make sway is equal to 0. That is our purpose. So what they have done basically, they have placed the bracing member like this, right? They have placed the bracing member, due to which whatever sway component you have, they are becoming 0, right? So let me show you guys how it is. So these are what? These are basically bracing member. These are basically bracing member, like this. These are basically bracing member. Why we have placed it? To make this particular displacement value as a 0. If you make it 0, then now tell me guys, in such condition, which is basically braced condition or braced frame, what is the value of dk? It is equal to 9. Now it is 9. Now I think you are able to understand how to calculate in case of braced frame and unbraced frame. Whenever you have a braced frame, so try to understand, avoid any kind of sway component which is present in the structure, or make it 0 basically, right? If you use the formula, you will not get the answer correctly guys, because you can understand there is no you can say that there is no value of braced member in this particular formula, and we are not able to put it in this particular formula also, because as per our derivation we didn't consider any kind of bracing condition for this particular formula. That is the reason. Okay, crystal clear to all of you? So the value of dk is 9. So answer is 9 basically. The answer is 9. I hope all of you are able to understand this particular problem very well. Clear? Let's move to the next question. Now let us understand what it is exactly. We need to find out the value of dk and ds. Please find out static indeterminacy and kinematic indeterminacy. Very simple. To find out the value of ds, we'll write here ds is equal to dse plus dsi. So the value of dse is equal to how much? Re minus 3. Now how many reaction we have? At this support we have 3 reaction. At this support 2 reaction. So total reaction is 5. 5 minus 3, it is equal to 2. Okay sir. What about dsi? dsi is equal to how much? You can see here guys, this is an open structure. If it is open structure, we can write here 3 into 0 minus r dash, and it is equal to 0. That means 0 plus 2 is equal to 2. So you can say that the value of ds is how much? It is 2 basically. The value of ds is equal to 2 sir. The value of ds is 2. Okay sir. What about dsi sir? What about dk sir? What about kinematic indeterminacy? So kinematic indeterminacy is equal to how much? You can see here guys, only one joint rotation can be possible. This is theta 1. Only one joint rotation can possible in this particular structure, that is basically theta 1. So we can write here dk is equal to how much? Dk is equal to 1. So the correct answer will be 2 and 1. 2 and 1 is the correct answer for this particular question. I hope all of you are able to understand this very well. Clear? Okay guys, so let's move to the next question, which was asked in GATE 2014. And what they are asking basically, find out the value of dk and ignore or neglect the axial deformation, right? Ignore the axial deformation basically. So guys, can I write here the value of dk is equal to how much? 3j minus re minus nr plus r dash. So how many joints we have? 1, 2, 3, 4. So 3 into 4 minus re. How many reaction we have? This is basically 3. This one is 2. So how many reaction we have? 5. Minus nr. How many members we have? 1, 2, 3. So 3 members are axially rigid, but it is written over here. Yes, it is written. R dash is how much? R dash is 1. So we can write here 1. So guys, let us solve this. You will get the answer. 12 minus 8, that is 4. 4 plus 1, 5. Right? I think one of the option is, means these two options are same basically. You can change it. So answer is 5 basically, which we are getting over here. Right? dk is equal to how much? dk is equal to 5 for this particular question. Next question. Do it guys and let me know the answer correctly. What will be the answer for this particular question? Please read the question very carefully and let me know the answer. And this particular question is basically an MSQ question. This one is MSQ question. MSQ question. Do it guys quickly. And let me know the correct answer for this. What will be the correct answer for this particular problem? Which of the following conditions are true? That you have to tell me. Out of these 4 options, which of the following options are correct basically? Okay guys, let us understand this. There are basically 3 joints which we have. One is A, C and B. Okay, first A, second B and third is C. Now each and every joint will have certain displacement, certain rotation. But as per their support condition, the rotation and displacement value may be 0 or may not be 0 according to their support condition. We know that guys. If it is fixed, then all 3 joint displacement is 0. If it is free end, then all 3 joint displacement can be possible, right? So as per this particular condition, we need to understand which of the joint displacement is 0, which is present in this particular structure. Okay, so guys, you can see here, basically this is joint A, where we will have hinge support, and at the hinge support there are basically 2 external support reaction. One is vertical and second one is horizontal, right? One is vertical and second one is horizontal. Now tell me guys, at this particular support, we know that delta AY should be equal to 0 and delta XA is also 0, because at this particular support we have 2 external support reaction, and that's why these 2 displacement will become 0. What about B? We know that delta YB should be 0, but delta XB cannot be equal to 0, and theta B is not equal to 0. Similarly, theta A is not equal to 0. What about this? Not equal to 0, not equal to 0, not equal to 0. Correct? So guys, what they are writing, delta XB and delta XC are equal and non-zero. Yes, it is correct. Both are equal. These 2 values are equal and they are non-zero. Okay, sir. Delta XB, delta XC and delta XA are equal. Wrong. Because we know that delta XA is 0. Delta AY is equal to delta YC is equal to delta YB. We know that delta YB is 0 and delta Y is also 0. So tell me guys, delta YC can be 0 or not? Listen very carefully, then only you can understand this particular point very well. Okay. Tell me guys, if you have delta YB 0 and delta YA 0. So this particular joint can have some vertical displacement or not. That means delta YC is present or it is absent. That is my question. Please write down in the chat box guys quickly. Delta Y is 0, delta YB 0. So can this particular value delta YC is 0 or not equal to 0? Right now it is not equal to 0 because it may be possible we will have certain displacement at this particular joint, right? So that's why this statement is wrong. Next, theta C is equal to theta C of beam and column. So this is joint C. We know that this joint is rigid joint. So whatever deflection or whatever slope which is formed by this particular beam, that same slope will be formed by the column also. That's why guys, D is correct. So A and D are the correct answer for this particular question. Clear? Next question. We need to find out how many sway components are present in the kinematic indeterminacy for the given structure. You do not have to find the complete value of dk. Just find out the sway component. How many sway component can be possible? How many sway component can be possible in this particular structure? So let me show you that. It is very easy. Guys, this is one of the portal frame and this is other portal frame. Both portal frame can have sway in the horizontal direction. So we'll write it down. This is 1, this is 2. Similarly, this portal frame and the backside portal frame will have sway like this. That means total sway component is basically 4. 4 sway component can be possible in this particular structure. 4 sway component can be possible in this particular structure. Clear? Now this is basically an MSQ question. Okay, let us understand how we can solve it. Okay, there are basically 4 statements which is given to us, and we need to solve the question first, then only we can take the correct answer, right? Okay sir, so we need to find out which of the following statement are not true. We need to find out those statement which is not true. Not true, which is not true, right? Not true. Okay sir, so let us find out the value of dk first for this particular structure. The kinematic indeterminacy of the structure when member are extensible and member are inextensible. We'll try to do it. So dk is equal to 3j minus re minus nr plus r dash. So how many joints we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of reaction. This is basically this should be fixed. So if it is fixed, then what will happen? Let us understand, guys. 3 reaction, 1 reaction and 2 reaction. Total number of reaction is 6. Minus nr. How many member we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of member is 10 and reaction release is 0. So guys, if we calculate this particular value, so it is 27 minus 16. Or let us write like this first. When the member is extensible in nature. If it is extensible in nature, then you need to consider nr as a 0. So 27 minus 6, it is equal to how much? 21. So when member are extensible, right? So it is 21. So kinematic indeterminacy of the structure is 21 when member are extensible in nature. So this statement is true. Okay sir. If member is inextensible, then what should be the value of dk? So we can write here 21 minus how many member we have? 10. Correct? We have calculated it. So it is 11. So when the member are inextensible in nature, then the value of dk is 11. So this statement is false. If roller support is replaced by free end, this roller support is replaced by free end on a smooth surface, then kinematic indeterminacy will remain same. Yes, it is so. Why, guys? If you consider this particular support as a free end on a smooth surface, still you will have only one vertical reaction, right? Only one vertical reaction. So there is no change in this particular calculation, and that's why this statement is true. It is true. If all the support will become fixed, then kinematic indeterminacy is increased in the structure. Guys, tell me, if you increase the value of RE, why? Because you are trying to make all the support as a fix. So if you fix it, then the total number of external support reaction will get increased. If this value is increasing, definitely the value of dk will decrease. But what they have written, if the supports become fixed, then kinematic indeterminacy increase in the structure. So this statement is false. Now what we need to do? We need to find out which of the following option are not true. That means this is our answer and this is our answer. Clear? So A and D is the correct answer for the question. A and D is the correct answer for the question. Clear? Next question, knot type problem. You need to find out the value of dk. Find out the value of dk when the member are axially rigid. When member are axially rigid. Do it, guys, quickly. and please let me know the answer. Do it, do it, do it. Do it, guys, quickly. Done? Okay. Listen very carefully. The value of decay we need to calculate. Okay. But guys, what we will do, we'll try to draw it on the figure itself. Okay. So it will become very easy for us. Let us understand, at this particular joint, we have two rotation, theta 1, theta 2, and delta 3. At this particular roller support, we will have theta 4. This one is theta 5, theta 6, and delta 7. Then 8, then 9, then 10, and this is 11. So these are basically our joint displacement, and total value is basically 11. Total value is basically 11. I hope you are able to understand this. Okay, how to calculate it. Next question. Again, you need to find out the kinematic indeterminacy, and this is basically a MCQ question. Let us solve it. Very easy. So guys, let us draw it directly on the figure itself. Okay, and we'll take the answer. So for this particular joint, we will have 4 rotation. 1, 2, 3, and 4. And this one is 5. Okay, sir. This one is 6. Then for this, we will have horizontal displacement 7. Okay. Then 8. 8. And this is a free end. So 9. And horizontal one 10. Okay. Okay. Then this one is 11. 11. Any other joint displacement which can be possible? Any other joint displacement which can be possible, because they didn't given anything regarding the axial axially member are inextensible or extensible. Such type of condition is not given in the question. Just we need to count how many joint displacement can be possible for the structure. Very easy, right? So guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Then this particular joint can have, okay, what we will do, guys, let me write it first, then I will explain it. 3j minus re minus nr plus r dash. Okay, let us do it. So how many joints we have? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 joints. Reactions 3, 3, 2, 8, 9, 10, 11, 12. Let us count once again. 3, 3, 6, 6 and 3, 9, 9 and 3, 12. NR consider 0. Reaction release at this particular joint, we have some reaction release, and we can write it m dash minus 1. So total number of member is 4. 4 minus 1 is equal to 3. So this is 3. So 24 minus 12. It is 12. 12 plus 3, 15. So total joint displacement is 15. Right now we have drawn up to 11. Okay. Let us write it. 12, 13, 14, and 15. So these are basically our joint displacement which can be possible in this particular structure. So that's why the correct answer is D. D is the correct answer for the problem. Okay. D is the correct answer for the question. Okay. Let us solve the next one. Let us solve this particular question which is given to us. Now you need to read the statement, guys. Which of the following statement is or are true? Okay. First, due to change in support condition, static and kinematic indeterminacy will get changed. Yes, both the value will get changed. Why it is so? Because we know that the value of DAC will depend upon the RE reaction, and the value of DK will also depend upon the RE value, right? So if you change the support condition, then the value of DK and DS will get changed. So that's why first statement is 100% correct. Okay, sir. Increase in support reaction will increase static indeterminacy and kinematic indeterminacy of the given structure. No. We know that if the value of RE will increase in case of DS, so DAC will increase. But in case of DK, if it is increasing, then the value of DK will decrease, right? That's why second statement is wrong. When the member are axially rigid, then structure will become unstable. Such type of statement is itself is wrong, guys. It is not true. Whenever your member is axially rigid, how you can say that it is stable or unstable? It will not depend upon that, right? So guys, only first statement is correct. That's why C is the correct answer for this particular question. Okay, C is the correct answer. Next one, GATE 2004. We need to find out the value of DS and DK. Very simple. So let us write down DSE is equal to how much? 3 reaction, 2 reaction, 1 reaction. So total reaction is 6. 6 minus 3 is equal to 3. DSI is equal to how much? 3C dash minus R dash. So guys, open structure, that's why it is 0. So overall DS is equal to how much? DS is equal to 3. Okay, sir. What about DK? What about DK? Let us do it. So DK is equal to 3J minus RE minus NR plus R dash. So how many joints we have? 1, 2, 3, 4, 5. Reactions 6. NR, right now do not consider it because it is not mentioned in the question. So 15 minus 6, that is equal to 9. So 3 and 9 is the correct combination. That's why B is the correct answer for this particular problem. Next one, we need to find out the value of DK when the axial deformation of the structure is to be neglected. Okay, sir. So DK is equal to 3J minus RE minus NR plus R dash. How many joint we have? Let us count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total number of joint is 11. What about reactions? 3, 2, 5, 6, 7, 8. Okay. Again, 3 reaction at this support, 2 reaction at this support, 1 reaction at this support, and 2 reaction at this support. So total number of reaction is 8 basically. Now consider NR. So you need to count the number of axially rigid member. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total number of member are 11. What is R dash? 0. So 33. 3 into 11 minus 8 minus 11. So guys, this value is coming around 14. This value is coming around 14. 14 joint displacements are there. So B is the correct answer for this particular question. Next question, guys. Just do it by yourself. I am giving this particular problem as a homework. This question, just try it. You need to find out whether it is indeterminate as a first degree, second degree, or like this. Okay. I think this is the last question which we have to discuss for this particular session. Okay. So the next question is, you need to find out how many compatibility equations are required to analyze this particular truss completely. Okay. To analyze this particular truss completely. So what you need to do, guys, you need to find out the value of ds. So ds is equal to DSE plus DSI. Correct. So first we will calculate the value of DSE, which is RE minus 6, because it is a 3D truss. Now you need to see how many supports you have and what are their condition. So 1, 2, 3, 4, 5, 6, 7, 8. Total 8 supports are there, out of which 4 are roller and 4 are hinge. That means 2 into 4 plus 4 into 1. Total reaction is how much? 2 into 4, 8, and plus 4, 12. So 12 minus 6, it is equal to 6. That means DSE is equal to 6, sir. Now what about DSI? How we can calculate it? What is the value of DSI? What is the value of DSI? Let's calculate it, guys. So to calculate the value of DSI, we need to count the members. Let me write the formula first. DSI is equal to how much? M minus 2j minus, sorry, M minus 3j minus 6. Correct? So we need to count the member first. Let us count it. So I'm trying to draw the front part. This is our front part. Let us count the members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total members are 15 basically. Oh, not total. For front part it is 15. Let us write like this. For front part it is 15. For front it is 15. The same thing is present in the back side also. So we'll write down 2 times of 15. Plus. Now guys, you can see here at the top we have some member 1, 2, 3, right? 1, 2, 3. And at the bottom we have 4, 5, 6, 7 and 8. Right? At the bottom 5 member, at the top 3 member. That means it is 8. So we'll write here 38 is the members. Total number of member is 38. Okay, sir. What about joints? Let us count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So total number of joint is 16. So let us write it down. 38 minus 3 into 8 and 8, 16. 16 minus 6. Let us solve this. What we are getting exactly? It is minus 4. Let us check once again. 38 minus 3 into 16 minus 6. Yes, it is minus 4. So plus 6 and minus 4, it is equal to, ds is equal to 2. But guys, as per our option, we don't have any option like 2. That's why D is the correct answer for this particular question. D is the correct answer for this particular question. I hope each and every student is able to understand each and every question over here, right? So guys, these are the questions which we want to discuss today. And I hope all of you are able to understand each and every question in detail. Okay. This is our Telegram, guys. You can join our Telegram. Or either you can search Krishna Yadav Sir PW. If you search it, you will get my Telegram, and kindly join that Telegram so that you will get the link of the session as well as the PDF of the class, right? Okay guys, so this is all about for today. We have done our all the question which is required as per the kinematic indeterminacy portion, and I hope you have understood it very well. Okay. So let's close the session. Let's meet tomorrow, guys, at the same time, in which we will discuss the further things. Okay, Bhanu, thank you so much. Let's close it, guys.